In this section, we're going to discuss symmetry of functions. So example 1 just says, determine if the following points are on the graph of this equation. Okay, so all we're going to do is point in or plug in for x and y and solve. So we've got 3 times 3 minus y, which is 2, equals 9. 3 times 3 is 9, and 9 minus 2 is 7, which isn't equal to 9. So that means the point 3, 2 is not on the graph of the equation 3x minus y equals 9. And for the same equation, we're going to plug in this point. So 3 times the x value of 2 minus a y value of negative 3. And we'll see if that equals negative 9. So we've got 6 plus 3, not negative 9, positive. And that equals 9. So the point 2, 3 is on the graph. Symmetry. Graphs can be symmetric with respect to the x-axis or the y-axis or the origin. If you're symmetric with respect to the x-axis, then that means that any point xy will, the point x negative y will also be on the graph. So y and negative y. If you're symmetric with respect to the y-axis, the point negative xy will always also be on the graph. So let's look back. Symmetric with the x-axis would be maybe something like this. So if this were the point 3, 2, then this would be the point 3, negative 2. Symmetric with respect to the y-axis might be something like this, where the point 3, 2 would be the point negative 3, 2, also on the graph. And symmetric with respect to the origin means that negative x, negative y is also on the graph. So it might be something like this, where the point 2, 2 is also on the graph with the point negative 2, negative 2. And here's some more examples of that. How do you test for symmetry? Well, you do just by the definition. To test if it's symmetric with respect to the x-axis, you plug in negative y for y. For the y-axis, you plug in negative x for x. If you get the same equation, then it's symmetric. And then origin, you plug in both negative x and negative y. And if you get the same equation, then it's symmetric with respect to the origin. So for example 2, we're going to test for symmetry, all 3 types. So first, with the x-axis, we take our function and we're going to plug in negative y for y. Then we solve it for y. So we just basically get the negative over. So if we multiply both sides by negative 1, then we have negative 6x squared over x squared plus 2. Now you can see that this equation is different from this one. So that means it's not symmetric with respect to the x-axis. Then we'll test for the y-axis. So for the y-axis, we plug in negative x for x. Negative x squared is negative x times negative x, which is positive x squared. So 6x squared, and then we've got x squared, and then plus 2 on the bottom. Now you can see that these 2 equations are the same. So we know it is symmetric with respect to the y-axis. Unlikely that it would be symmetric with respect to the origin also, but let's test it just to be sure. So we plug in negative y and negative x. So we have negative y. Well, go ahead and get that negative over. And then the negative x squared becomes positive x squared. And you can see again that we're not the same. So not symmetric with respect to the origin. So we can say that the graph is symmetric with respect to the y-axis. For example 3, we're going to graph this equation, and it says find intercepts and check for symmetry first. So let's find the intercepts first. To find an x-intercept, then we plug in 0 for y. So x would be, that's a 3, 0. So an x-intercept would be at the point 0, 0. To find the y-intercept, we plug in 0 for x. So it's the same point. The y-intercept is also 0, 0. Now we'll test for symmetry. So for the x-axis, we plug in negative y. Not the same, so not symmetric with respect to the x-axis. For the y-axis, we plug in, I wrote that wrong, negative x. Negative x cubed is negative x cubed. So not symmetric with respect to the y-axis. And then the last one, we plug in negative y and negative x. I keep doing that. So if we divide by negative 1, we see we get y equals x cubed, which is the same. So we are symmetric with respect to the origin. And then we want to graph it. So let's pick some points. We'll do negative 1, 0, 1, and 2. So if we plug in negative 1 for x, then we get negative 1. If we plug in 0, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. So we have the points negative 1, 0, 0, 1, 1, and 2, 8. So let's go over here and plot these. Looks like a line until we get to that last one. It's actually doing something like this. And since it's symmetric with respect to the origin, that means it's doing the same thing on the other side. So since the point 2, 8 is on the graph, then the point negative 2, negative 8 will also be on the graph. And so that's what it looks like. For example 4, we're going to do the same thing. Had to change this, but we should have y equals x squared. And so we're first going to find the x-intercept. So we plug in 0 for y. So the x-intercept is at the point 0, 0. For the y-intercept, plug in 0 for x. So point 0, 0 is also the y-intercept. Now we'll check for symmetry. For the x-axis, let y be negative. So no, we're not symmetric with respect to the x-axis. For the y-axis, let x be negative. And we do get y equals x squared. So yes, it is symmetric with respect to the y-axis. And then the origin, no, it's not symmetric with respect to the origin. So on the next page, we're asked to graph this. So let's graph the points -1, 0, 1, and 2. Remember, we're plugging into y equals x squared. So -1 squared is 1, 0 squared is 0. 1 squared is 1. And 2 squared is 4. And it looks like my graph is wrong. Well, we'll do it the best we can on here. I'll fix it. I'll make sure it's fixed on your paper. So I'm going to go on over here, extend this out a little bit. So there's -1 and there's -2. Okay, so the point -1, 1, 0, 0, 1, 1, and 2, 4. And since this is symmetric with respect to the y-axis, then the point -2, 4 is also on the graph. So we have a parabola. Part B asks us to then graph x equals y squared for, this should say, x is greater than 0. Okay, so what does that mean? Well, if you want to, instead of graphing y equals x squared, you want to graph x equals y squared, then we're just going to take the points from the other graph and switch them. So we've switched the x and y here, switched the x and y on the points. So we've got the point -1, 1, 0, 0, 1, 1, and 4, 2. So let's see. Oh, I wrote that wrong. It should be 1, -1. Okay. So 1, -1, 0, 0, 1, 1, and 4, 2. Now, since y equals x squared was symmetric with respect to the y-axis, then guess what? X equals y squared is symmetric with respect to the x-axis. So this point is also down here. And so what we get is a parabola turned on its side. This time we don't have a function, but it still is a graph. And you'll see in coming sections why we did that, okay? Okay, and the last example, it says graph the equation y equals 1 over x. First, find x, y intercepts and check for symmetry. So same thing. To find the x-intercept, we let y be 0. So x times 0 is 0. We don't have anything here. There are no x-intercepts. For the y-intercepts, we let x be 0. So if we can't divide 1 by 0, so this is undefined, which means, again, there are no y-intercepts. Let's test for symmetry. For the x-axis, we have let y be negative. So we have y equals negative 1 over x, not symmetric with respect to the x-axis. For the y-axis, let x be negative. Nope. And then origin, let y be negative and x be negative. And so in this case, we get y equals 1 over x, which means yes, it is symmetric with respect to the origin. And we're asked to graph it. So we're going to use several points here to make sure we get enough on the graph to see what's happening. We're going to use -4, -1, -1/4. We're not going to use 0 because we already know it's not there. 1/4, 1, and 4. So remember, we're plugging into y equals 1 over x. So 1 divided by -4 is -1/4. 1 divided by -1 is -1. 1 divided by -1/4 is -4. 1 divided by 1/4 is +4. 1 divided by 1 is 1, and 1 divided by 4 is 1/4. So we'll plot these points, -4, -1/4, something like that. -1, -1, and -1/4, -4. And then we have the point 1/4, 4, 1, 1, and 4, 1/4. So we already know it's not going through the origin. So what this actually looks like is this here. And this is another one of those common functions you'll see fairly often, y equals 1 over x.